Yeah. Okay, so welcome everyone. We are very happy to welcome today Madarena Conte, PhD student at CREST, who is going to present her work regarding the volatility advantages of dense labor market. So I'm going to give you the floor. You have up to 50 minutes to present. If anyone has a pressing question, you may intervene, either in the chat or directly, and we will leave more time for discussion after the presentation. So you may start.
All right. Hi, thank you so much for coming today. So I'm going to present this project called Churning in Cities, the Volatility Advantage of Dense Labor Markets. And this is joint work with Isabelle Méjean, Tomasz Michalski, who is in the audience, and Benoit Schmutz. Okay, so I'm going to, oops, does it work? Yes, okay. So I will jump straight into the motivation and research questions of this project. And so the paper starts from the well-known fact of the productivity density nexus, which is a central tenet of economic geography and urban economics. And it's the idea that the more productive firms tend to locate in the larger or more denser cities. And this is actually what we show as well in this figure, where we plot average productivity across commuting zones in France against the density of the working age population in the same commuting zones. And you can see pretty clearly that the slope is increasing. There's a strong positive correlation between productivity and density of cities. And the literature has for a long time tried to explain this relationship between productive firms and dense cities. And agglomeration economies have been put forward as explaining why productive firms sort into larger cities. There are many different mechanisms which you might know very well: learning, sharing, and matching. And we are going to focus on one specific type of mechanism within matching agglomeration economies, which are pooling externalities. So the idea that high productivity firms benefit the most from being able to hire more quickly. And this is something that they can do in thick labor markets where it is easier to sort of adjust the labor demand. And this is exactly what dense or large cities offer. So thick labor markets where it is possible to adjust. And so what we argue in this paper is that pooling externality benefit not only the more productive firms, but also firms that are more volatile. So by this, we mean firms that have volatile demand and that therefore need to adjust their size to respond to volatility of their activity. And then cities enable them to do this. So they enable them to churn. That's the terminology that we use in the paper. So then cities are conducive to churning, and this benefits especially very volatile firms, but crucially, even if they have low productivity. And this is something that we will come back to, because the literature on the productivity density nexus has sort of highlighted this puzzle, the low selection puzzle, which is that even though more productive firms benefit the most from being in larger cities, there are still quite a lot of low productivity firms that remain in large cities, and that's something that we are going to be able to speak to in this project. Okay, so what do? We start with some empirical facts about firm labor churning across cities. And the way we will measure this firm labor churning is through employment volatility, and I will explain this in a lot of detail very soon. But kind of the key conclusion from this empirical analysis is that there is a positive correlation between churning and city density, just like we see for productivity. And based on these empirical facts, we develop a theoretical model that tries to explain what the mechanisms at play might be. And in particular, the theoretical model focuses on the relationship between some key firm characteristics, which are this volatility of the activity of the firm. We will focus on the demand side of this volatility, so firm demand volatility, productivity, and labor churning on the one hand, and then city size on the other. And with this theoretical model that gives us some insights of what might be going on, we then go back to the data in the last part of the project, and we develop an empirical model of firm location choice, which will show that firm demand volatility is as predictive of location choice as productivity. All right, so
sorry, then to perfectly understand, then that means that what you're interested in the sorting of firms rather than agglomeration economies that make firms in large cities more productive due to this, or is it both at the same time? I'm not completely sure to understand your contribution then.
So I think it will be a bit more clear when I also look at, when I show the model, but basically we sort of assume that productivity and the volatility of the activity of the firm are sort of given, so they are sort of fixed for the firm. Okay. And then given these characteristics, the firm chooses a location which enables it to kind of be more profitable because of these characteristics. And because of the characteristic of the city that enables it to churn or not. So I'm not sure if this is super clear, but I think it will be clear.
No, so then you're more interested into the sorting of firms into different types of cities. I understand. Yes. Okay, thanks.
Okay. So if there are no more questions at this point, I will jump into the empirical facts. So how do we look at this question? We use French matched employer-employee data between 2010 and 2019, and we develop a measure of labor churning, which captures both positive and negative labor demand adjustments. We focus on 12 sectors, which are manufacturing, construction, services, and this also includes non-tradables. And in the rest of the presentation, cities are defined as commuting zones. There are 280 of them in France, in the continental France. That's what we focus on. And then when we talk about our measure of city size, we will actually refer to the density of working age population. So this will be our measure of urban scale. Okay, and so how do we measure firm labor demand volatility? We use a measure that has been developed by Davis et al. 2006. And so for each firm F and month T, we calculate the standard deviation in the growth rate of employment at the firm. So what this growth rate really is, it's the growth rate in the number of employees between month T minus 12 and T. So it's a year-on-year growth rate. So we're basically comparing the same month in 2 consecutive years. And then we calculate the standard deviation over a window of 35 consecutive periods. So it's approximately 3 years. And then the remaining variable in the formula is this gamma bar, which is just the mean value of the growth rate over the period. Okay, and before I show you the empirical facts, I just want to give you a bit more intuition about what this measure is, which firms are churning based on this measure of employment volatility. And so to do that, we regress the log of this employment volatility measure on commuting zone density, the log of commuting zone density. And this first column shows that basically there is a positive correlation between volatility and commuting zone density. We then add some firm characteristics, which basically show that churning seems to be more prevalent among smaller and younger firms. And when we also think about, when we add productivity, it seems that the relationship is positive, although relatively small. And finally, we also control in the third column for fixed term contracts, which is basically the share of CDD, fixed term contracts in France, to just show that although the correlation is positive, so the correlation between this churning measure and the share of CDD is positive, it doesn't really explain all of the variation that we observe. Okay, and so
it went a little bit fast for me. So how should we think about the firm's dynamics in that setting, in the sense that how your measure of churning is correlated with firms' growth in terms of size. Because you say that, I mean, it happens, small firms tend to churn more, but is it just due to the fact that they are growing more? I mean,
yeah, so that's actually something that we're doing right now, really understanding a bit more what this churning means. And one of the latest things we looked at was exactly this. So is basically the growth rate correlated with this churning? And yes, it is. So firms that grow faster, they churn more. But actually all our results are robust to controlling for the growth rate. So
okay, no, I mean, my question was not related to robustness, or it's more about curiosity. Which type of firms we need to think about? Is it like new firms, etc.?
Yeah. So
in which sectors?
Yeah.
I mean,
so
having some, given I don't know the literature, maybe this churning stuff is well defined and etc. But if it's not, I mean, having some standardized facts about what we're talking about, I guess will help.
Yes.
A little bit.
No, exactly. I totally agree. So here we have a few ideas that smaller, younger firms. So your question about age of firms, we try to answer it like this, but that's actually what we're working on now. So giving a bit more meat to what this churning measure is. But yeah, as I said, smaller firms churn more, firms that grow faster churn more, younger firms churn more. And actually what we will do in the next phase is really kind of understanding along which dimensions firms are churning, with which kind of contracts. Do they churn more low-skilled workers and so on? So that's, but I don't know that yet. I will.
Yeah, and also are those firms that churn a lot, are they going to disappear in a few years? Because I guess many firms die as well, no?
Yeah.
So, I mean, yeah. All that would be very interesting for motivating facts.
Yes, and yeah, I don't have the answer yet, but I've taken note. Thank you very much. Okay, so where were we? Yes. Okay, so the next thing we do is try to establish some empirical irregularities in the data. And the first thing that we argue is that labor demand volatility increases with city size. So here we're doing exactly the same exercise as the first chart with productivity. So we're plotting average labor demand volatility against the log of the commuting zone density. And in the first, so the blue dots are conditional on some firm characteristics like the sector, the age, and the size of the firm. And in the red dots, we also control for productivity. So I didn't mention this in the first graph with the productivity density nexus, but it was also conditional on these firm characteristics. And so what we show is that labor demand volatility increases with city size, and that's the first kind of novel fact. And the second one is that the productivity density gradient that I showed you at the very beginning actually decreases with this measure of labor demand volatility. So the kind of tendency of the most productive firms to locate in larger cities seems to be less pronounced for firms that are more volatile in the aggregate. And actually this is quantitatively non-negligible. So if we go from the first to the ninth decile, the coefficient, this cross correlation is halved. Okay, so these are just some of the empirical facts that we will enrich further. But what we did next is try to kind of build a theory that gives a bit of intuition of what might be going on. And we have a very simple setup that is inspired by Mortensen and Pissarides, 1994. And here we are really focusing on the firm's decision to churn. So we kind of simplify the worker side as much as possible, and we lay out the problem of single job risk neutral firms in continuous time. So again, because we are just focusing on the firm's decision to churn, we are in a partial equilibrium setup where workers are homogeneous, immobile, they just always accept jobs and they don't search, and the economy operates a steady state. But then while workers are homogeneous, firms are heterogeneous, and they're heterogeneous in terms of two key dimensions. One is productivity P. And one is demand volatility epsilon, so kind of the volatility of the firm's activity. And both of these are known ex ante, and they're sort of fixed for the firm. And then given this heterogeneity, sales will fluctuate between a high state, H, where the firm can sell P times 1 plus epsilon, so it's sort of a positive shock, and a low state, P times 1 minus epsilon. And they fluctuate at the rate sigma, which is the same for all the firms in the economy. So this is not heterogeneous. And so given this simple setup, the firm has to make two choices. It has to choose a location, M, and in this setup, the M is also kind of the size of the city, and it corresponds to some operational costs, R of M, and a job filling rate, mu of M. And we assume that operational costs are increasing in city size, and the job filling rate is non-decreasing in city size. And then we also argue that the firm has to choose a strategy, which is what to do in a low state. So when the firm is hit by a bad shock and can only sell a lower amount. And so we start with the business as usual strategy, which is sort of standard in these models. And in this strategy, the firm makes no adjustment to labor demand in the low state. So if it is vacant, it will keep looking for workers. And if it is filled, it will keep producing. And so this is kind of the standard strategy in these type of models, where firms choose their labor demand and then they don't really adjust. So they're sort of passive to volatility of demand of demand for their products. And then we add two more strategies where the firm is no longer passive and it can respond. And the first is a sort of intermediate strategy, which we call wait and see. So if the firm is in the low state and it is vacant, it's not going to hire. But if it is already filled, it will keep producing. And finally, we have churning, which is kind of the more extreme strategy. So the firm is always going to become idle, both when it is vacant. So when it is vacant, it's not going to look for workers and it will just be idle and wait for better times. And also when it is filled, in which case it will fire and become idle. So given these two choices of location and strategy, firms alternate between being vacant, filled, or idle. And so this gives rise to some value functions, which look maybe a bit messy and complicated, but actually are very simple. And I will explain to you two examples. So first one is when a firm is vacant and it's in the high state. So it has to pay the cost of posting a vacancy, C. And then with probability mu, it can hire, and so it becomes filled. So that's the F here. And then with probability sigma, it switches to a low state. And in that low state, it has to make a decision about its labor demand strategy. So it can do business as usual, wait and see, or churning. And so this is represented by this W, which changes depending on the strategy that is adopted. And then if it's instead filled and in the high state, it can produce this P times 1 plus epsilon. It has to pay some operating costs that depend on the city size. And then it might become vacant with an exogenous match destruction rate of delta, or it might switch to a low state with a probability sigma. And that's again, something that will depend on the strategy that the firm adopts. And then there is the idle value function, which is relatively simple. Okay, so basically the strategy is really what determines how the firm transitions to a bad state when it's either posting a vacancy or when it is filled. And so these kind of standby values W and C are then filled with a corresponding value depending on the strategy. I'm not going to bore you with this, but I think the key is that you remember this intuition about business as usual, which is when the firm just doesn't respond to changes in demand and so on. And so then given these strategies, expected profit is given by basically the value of being vacant in the high state and the value of transitioning to a bad state when posting a vacancy. And this is because the firm doesn't really know the state when it enters or in all future states. And then given this expected profit, at entry, the dominant strategy is just the one that maximizes expected profit. And so the first thing that we can do is show what the model implies when the location is fixed along and the firm is characterized by its productivity and demand volatility. So You can see productivity on the y-axis and demand volatility on the x-axis, and the strategies are represented by these colors. So red is business as usual, W is this wait and see intermediate strategy, and churning is the green one. And so given a location and given these characteristics of productivity and demand volatility, what this figure implies is that churning is adopted by more volatile firms. So you can see that as epsilon increases, churning becomes more popular strategy. And also churning allows more productive firms to operate. So you can see that the minimum productivity cutoff to operate is lower when firms adopt the churning strategy. So these are kind of some key takeaways from the model. And however, what we really want to look at is not just the strategy that firms adopt given a location, but the simultaneous choice of strategy and location. And to do that, we make some additional assumptions, which are relatively straightforward. So one is that churning actually happens in equilibrium. So there are some firms that adopt this churning strategy, and this requires a sufficient condition that operating costs R of M are greater than the cost of posting a vacancy, and that the job filling rate mu is greater than the probability of switching to a bad state. We also assume that selection on productivity increases with density, and that there exists an optimal density for operating firms. And so given these assumptions, we can then think a bit about comparative statics. So we can see, okay, what does the model imply if we compare a small city A and a large city B? So here, again, we're depicting the strategies in the different colors that depend on the kind of productivity and demand volatility that firms have. And the two key takeaways from these figures are that dense cities have a higher share of churning firms. So you can see that in the B city, the C strategy is much more popular than it is in the small city. And then low productivity firms are more volatile in denser cities. So in a sense, what we're saying here is that productivity and volatility are sort of substitutes for allowing entry of firms into cities. And you can see this from the slope of the curve in the larger cities, which is steeper here than in the small city. Okay, and finally we say, okay, let's actually solve the joint strategy location optimization problem, which we do by numerical simulation. And I'm not going to show you that here. I just want to highlight the key takeaways that this yields. So the first is that, okay, more productive firms gain more from hiring fast. And that's kind of what we know already from this literature on pooling externalities. But what is novel is that also more volatile firms benefit more from being able to churn. And we can also combine the two. And so churning is actually more profitable for firms that are more productive as well as volatile. So there's a sort of complementarity between productivity and volatility. And so when we solve the model by numerical search, we obtain this picture, which is very familiar by now. So it looks kind of like what we had before. And so the key is that we preserve this ranking of strategies, and we can find kind of a unique solution. All right. So I've shown you some ideas of the model and some kind of key implications. I'm just going to sum them up here and relate them to the data. So relate them to the empirical facts that I showed you at the very beginning, and then highlight what we're going to look at in the last part of the paper. So in terms of, if we just look at location, we kind of don't really look at what specific firms are doing. What the model implies is that the share of churning firms increases with density. And that speaks to the first fact that I showed you at the beginning, that labor demand volatility increases with city size. I mean, the difference here is that in the model, we have a sort of yes or no churning strategy, while in the data, we have a continuous measure. But in a sense, the two things are speaking to each other. And the second is that the productivity density gradient decreases with volatility. And again, this was something I showed you earlier on in this figure. Okay, and then there are some implications of the model at the firm level. And the first is that more volatile firms sort into denser cities. And the second one is that more productive firms sort into denser cities, especially if they are more volatile. And these two things are what we're going to show in the next part of the paper. But before I do that, I just want to highlight again that this is just meant to be an illustrative model to kind of highlight the mechanisms or try to think about what the mechanisms might be. But to go macro, we would have to do many more things like specifying an underlying joint distribution of productivity and demand volatility. And here there are also no general equilibrium mechanisms. Okay, but then we can directly go to the location choice model unless there are questions. Okay, so in the next part, so in the final part of the paper, we develop this firm location choice, and the goal is to show that all else equals, firms sort not just on productivity, which we already know from the literature, but also on demand volatility. And so to do this, we develop a one-stage discrete choice model based on the conditional logit estimator, so with firm fixed effects. And the location choice is driven by some factors. The first one is the size of the labor market. So it's what we measure by the density of working age population in a commuting zone. And then two key firm characteristics, which are the ones that we had in the model. So volatility, the epsilon, and productivity, the P in the model. And these are also interacted with the size of the commuting zone. And then we have some other factors that could drive the location choice. For instance, how skilled the labor force is in a location, which we measure with some proxies, such as the share of managers and the share of college-educated workers in a city. And then some more firm-specific reasons to locate in a city, for instance, localization economies, which is just a measure of the concentration of firms in a given sector. So in the same sector as the firm in each possible location. I think there's a question. Okay. Okay, so we are going to focus on a sample of new firm openings between 2020 and 2019. And we look at firm openings because we think that the location choice is more salient for firms that are for firms that are entering. Okay. And in this part of the model, in this part of the project, when we think about volatility, we no longer measure it with this employment volatility measure that we had before. So we no longer think about churning, and that's because we've shown with a model that churning is endogenous. So it's kind of the result of making the location choice and the strategy. And so we use a different measure, which is demand volatility, which is sort of capturing an exposure to macro demand variations. And the advantage is that it is orthogonal to the strategy choice of the firm, as well as to maybe more structural kind of churning characteristics of a local labor market. And so the way we measure it is exactly as we did before. So it's a standard deviation of a growth rate over 35 consecutive periods, but now the growth rate is something else. It's this synthetic demand indicator, which we measure using, first of all, data about the products that firm produces and that each firm produces and sells. So we have data on sales in each year for each product, and we look at the share of sales from a specific product over total sales. Then we go to Eurostat and we take import data at the product level. This is available at the monthly frequency. And we look at external, we are interested in external demand. So we look at world minus France. And we calculate this growth rate of imports. Again, it's this year-on-year growth rate. And then we multiply the growth rate by this W, so by this sort of exposure to shocks in a specific product. We sum across all the products of the firm, and we have this synthetic demand indicator of which we calculate the standard deviation, just as we did before. Okay, and just before I show you what this gives us, I just want to highlight the fact that we're focusing on new firm entries, and this means that the firms might be a little bit different from all the other firms. In the end, we are sort of, we see that they're not so different, especially among some dimensions that are important. So for instance, here we are comparing in-sample firms are those that we use for the location choice model, and out-of-sample firms are firms that have data on demand volatility, employment volatility, productivity, but they are not necessarily newly created. And so we can see that kind of newly created firms in our sample are in slightly smaller cities, and they are a little bit more productive, and they are a little bit less volatile. But in the end, demand volatility is not too different between the two groups of firms. Okay, so what do the results show? So in the first column, so it's the location choice model. The kind of dependent variable is the choice of a specific city. And in the first column, we only have one variable, which is the city size, so the M in the model. And this just shows that firms tend to be in larger cities, so very straightforward. And then in columns 2 and 3, we add first productivity, which we interact with city size, and then this demand volatility that we interact again with city size. And we see, okay, in column 2, the most productive firms tend to be in larger cities. That's what the literature says. But what we show on top of that is that it's also true for volatility. So the most volatile firms are also found in larger cities. And then in columns 4 and 5, we add both of these interaction terms, which gives us relatively stable results. And then also some controls, the ones that I explained at the beginning. And finally, in column 6, we have this triple interaction term. So we have city size, demand volatility, and productivity. And basically, we show that, in a sense, productivity and demand volatility are complements. So the most productive firms kind of benefit from locating in larger cities, especially when they're more volatile, and vice versa. More volatile firms benefit most when they're more productive. And so how do we interpret these results? With like these conditional logic model, it's a little bit not super intuitive, but one way to think about it is to look at the elasticity of the odds of choosing a specific city to that city density. And when we move along the distribution, for instance, of productivity or volatility. So this elasticity increases from 0.29 to 0.38 when we move from the bottom to the top of the productivity distribution. And it's relatively similar if we look at volatility. But I think a more intuitive way to think about this is to look at the predicted probabilities that result from the model. So for each firm, the model gives us a predicted probability of being in each location. And then what we do in this figure is we compare high and low productivity firms. So we look at productivity for firms that are in the top quartile of the productivity distribution versus firms that are in the bottom quartile. We take their probability of choosing a specific city. We take the average amongst this group of firms, take the ratio. So if the ratio is equal to 1, it means that high and low productivity firms are just as equal, just as likely to choose a specific city, which we sort of denote again by its density. If the ratio increases above 1, it means that more productive firms are more likely to choose those cities. And if it's below 1, it's the least productive firms. And so what this figure shows is that, so the red dots are with productivity. We do the same for volatility with these blue dots. So what this figure is showing is that these so high and low productivity firms are just as likely to choose a city which has a log density of around 5 that is in the top quartile of the density distribution. And it's actually the same with a bit more noise for high versus low volatility firms. And then above this density, the most productive firms and the most volatile firms are more likely to locate in larger cities. Okay, so that's kind of what the empirical results are showing at the moment. And that's basically the end of the project right now. We're still working on a lot of data to try to give a bit more meat to what these churning patterns really are, but I will just finish with some concluding remarks. So what this project tries to do is to bring to light some new facts about firm location. And kind of the key takeaway is that firms that anticipate a volatile activity locate in larger cities, even when their productivity is low. And that's, I'm kind of coming back to this low selection puzzle at the very beginning. So in the literature, there is this finding that even though the more productive firms are those that benefit the most from being in larger cities. Actually, there are a lot of low productivity firms in large cities, and we give sort of an explanation for this. We say, okay, even low productivity firms can locate in large cities if they're volatile enough because they can churn. And so dense labor markets provide a sort of insurance against volatility, and that's the advantage of large labor markets that we refer to in the title. And this advantage is the fact that in thick labor markets, firms can churn. But besides these kind of facts that we try to show both with data and a model, this project also maybe talks a bit to some debates on the spatial labor markets literature that have been going on, and in particular, two kind of key papers and models. Kuhn and co-authors 2022 and Bilal 2023 on two. So we speak to sort of two different topics. One is the idea of search and matching, but in particular, how to reconcile having a constant returns to scale matching function with a job filling rate that increases with city size. And we say, well, actually, in our framework, this makes a lot of sense because in larger cities, higher operating costs sort of make firms churn, and more churning loosens the market, which creates a sort of positive externality for other firms that can hire faster. So that's why the job filling rate can increase with city size. And this kind of connects to another question, which is the relationship between unemployment and city size, because in the literature, in fact, also in the data, actually unemployment doesn't decrease with city size. So if we look at France, there's this non-decreasing relationship, and I think again this paper can give a bit of intuition of why this is the case, because even though larger cities have better production factors and more productive firms, at the same time, larger cities also facilitate churning, and so this can maybe explain why unemployment is not necessarily lower in larger cities. So actually, there is a little picture of that for France. So the unemployment rate is plotted against the density of commuting zones again. Okay, so I think that's it. I was a little bit fast, but I hope it was understandable. And if you have questions, I'm happy to answer them.
Thank you very much. So the floor is open for questions. Please feel free to intervene. Okay.
Yes, I have one question. Thank you, Sophie. You mean that unemployment may not be lower, but it means in France, in your example.
Yeah, but there's also the same in the US, for instance. I mean, I don't have it here, but
okay,
yeah.
you have also the same results. Okay.
Yeah.
But do we have some ingredients about? I mean, ingredients are explanations about the labor market, the context of the labor market, and not only the city size or productivity factors in cities.
So you mean, sorry, can you rephrase the question? I'm not sure I understood.
I mean, do we have some explanation about how labor markets are in some states, some countries, which are different between cities?
Okay.
That's
so you are still thinking about the US versus France comparison, or?
Yeah, or other countries, because I think it's not the city size only, which explains why there are a higher level of unemployment.
Yeah, you're right. Probably there are other reasons.
Okay.
So I'm not sure. I didn't really look too much into this. But I mean, we'll try to say that one reason why unemployment is lower, maybe in larger cities, is because firms are churning much more, so they can adjust. And because of that, actually, in the end, there are more people that are let go of. I don't know, but I don't think this really answers your question, I guess.
Oh, it's okay.
Yeah. Okay.
If I may, I would, may I? Can you hear
Of
me?
course.
Okay, I would say that, you know, this is something that is understudied. So I'm Tomasz Mikalski, I'm one of the co-authors. Here, if you would think about the models of, say, Bilal or Kuhn et al., they would tell you the following: more productive firms go to larger cities and create more stable matches, and as a result, unemployment should be lower, but it isn't. So, you know, let's leave it at that. I don't think we're aware that the labor market, for example, institutions are different between large and small cities in the sense that there are different unemployment benefits or firing costs or stuff like this. There might be many other issues that are involved with exactly the fact that you have, for example, perhaps increasing returns in the matching function that are going to change the equilibrium level of unemployment. But this is, I would say, an open debate. So we're adding to that debate and saying, hey, we have a model, we have empirical results that say in larger cities, unemployment rates may be, in fact, not lower, which the current leading theories predict, but actually maybe not correlated, in fact, with city size.
Thank you so much, Tomasz. That was much clearer than what my answer.
Thank you. Any more questions? Well, I have one regarding your empirical strategy and the focus on entry firms, new firms. Maybe I missed something in your explanation, because you saw that in the end, your sample of new firms is not so different from general sample of firms. So why focus on them? You may lose them. I mean, it was not very clear to me.
Yeah, no, you're right. So we started because when we took the model, we were really thinking about, in a sense, the firm location. So firms that choose a location, and kind of it was maybe intuitive to think, okay, this decision is important when you actually create the firm. But in fact, as you say, given that the samples are not so different, we can look at all firms, and that's what we are actually doing now. So in a sense, what we're doing is extremely restrictive, and maybe we make kind of the most restrictive assumptions, but we don't need to do that, maybe. So we're gonna, that's on our to-do list. Thank you.
Thank you. Any more questions? Okay, because I'm going back to the remarks and questions by Clément Bosquet in the beginning about who are these churning firms, etc. And yeah, I mean, I guess you say that you are in a process of trying to have some more inputs, at least but yeah, it's puzzling what kind of firms this could be. And coming back to my previous question, focusing on entry, do you have data about exits of firms, of churning firms, and the dynamics, the demography of these firms? I mean, this would be interesting too, because I really have difficulties in anchoring what are there any sectoral characteristics, so yeah, maybe
yeah, so no, you're right. So in principle, we wanted to kind of control for all of this stuff. So we always have sector fixed effects, we always have a measure of the firm size, the age of the firm. So we try to look at what happens beyond these characteristics. But now, given that these questions are actually raised in all the presentations that we have had, we are actually trying to say, okay, what are these firms? What do they look like? How can we depict them? yeah, and about exit, actually, I didn't think about that, and I will look into it, but we have the data, so it's possible. I guess it would be nice to look at kind of the age profile of firms and how churning varies, and then also looking at entry and exit, maybe the first 2 years and the last 2 years of the firm live and see, yeah. But this will, in the draft, we will have this stuff, so I could share with you.
Okay.
Thank you very much.
And maybe I have a last point, since regarding this unemployment and city size, because I just opened back, because I remember a paper by Karl Guénier and Mathieu Sanche-Maritain regarding the specific theoretical paper. They have some empirical application on French data about city size and the risk of being unemployed, and the trade-off between job pooling and job competition, in which at some point they show that city size, if I'm not, I'm just checking if I'm not incorrect. A larger city may induce higher unemployment rate for some of the reasons that you may have mentioned, but also it reduces the variance of unemployment over time. So maybe I mean that's maybe something you would like to, if you are unaware of this paper, you may have a look, because it may be interesting to relate it to this demand volatility. So yeah, I guess.
So actually, can you maybe?
Yeah, I will send it.
Yeah, thank you so much. That would be super useful. Thank you.
Okay, we have time for more questions or remarks, if anyone wants to pitch in now. Okay, I guess the presentation was very clear. So once again, for all participants, Clément had to go, so he was apologizing for that and pointing out a very interesting and nice idea. So, I mean, I guess if there is no more questions, we may wrap up this seminar. Thank you very much again for presenting here. We are very happy to hear you, and well, thank you for everybody in the audience today, and we'll see you maybe at the next seminar, which date I don't have in mind, so we have to keep you posted through the usual canals. So thank you very much.
Thank you.
And have a nice rest of the day.
You too. Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you.
Thank you. Yep.